So in this video we're going to look at solving log functions. Now when we did the video on solving exponentials, we had to use logs as our skill to be able to pull that power down from our exponential. The reverse is true when we're solving logs. If we want to get a x outside of our log bracket, then we need to use an exponential to isolate that. So what you're going to see is solving logs and solving exponentials will often go hand in hand. Okay. Part A, we're going to solve, and you'll see that I'm going to rarely write log base e. We're going to solve ln x equals 0.5, and we're going to give our answer correct to 2 decimal places. So the first thing that I'm going to look at is I need to get this x outside of my log. So I'm going to do e to the power of ln x equals e to the power of 0.5. Now there's two things about this. The first is this e to the ln is actually just going to cancel out, and this x is not going to be a power. It's just going to be dropped down. The second thing is e to the power of 0.5 is not nice. We would rather write that as e to the power of a half, because when we're looking at things to the power of a half, that just means square root. Now this question itself says they would like the answer in 2 decimal places, so we can put that in our calculator and get 1.65 if we round it to 2 decimal places. Obviously, if we're looking at exact value solutions, I would much rather you write it as e equals root e. X equals root e. Alright, part B. Now we're going to solve 2 ln x minus ln 3 equals 4. And we're going to work out what x is. Now, these are both ln, which means log base e. And just like before when we looked at index laws, if I was doing something like this, x to the squared times x to the 3, it would be x to the 5, because they both have the same base. So we can do that. Now, as I said before, these are technically logs with a base e. So these are the same base logs. Now, before I can actually use a log law with them, I need to actually get rid of this pesky little number out the front. And you're going to see this log law come up quite often before you can use your adding or subtracting log law. So if I want to move this 2, what I need to do is put it back inside my bracket. So a 2 out the front is going to end up becoming a squared once you put it back in the bracket. Okay, the next thing we're going to look at is how do I deal with subtracting logs. If you have looked over your log laws recently, you'll know that when we are subtracting logs, it means that we are going to divide the terms inside my bracket. So ln x squared take ln 3 means it's actually going to end up with an x squared divided by 3. Now, once we've got one neat log, it means that we can do e to the power of, or do an exponential on either side. So what, again, that's going to allow us to do, e to the ln of x squared on 3 equals e to the 4. And the whole reason we do this is so that these cancel out, and it's just going to leave them with x squared on 3 equals e to the 4. Doing some rearranging, x squared equals 3e to the 4. And then lastly, I would need to do the square root of all of this, and it's going to be plus minus. Now, it says here that we need to give this answer in 2 decimal places. So if this is plus minus, it means I'm going to have 2 answers, right? I'm going to have x equals negative 12.80. Again, just put it in our calculator and get the answer out. And x equals positive 12.80. Now, normally, yes. However, let's think back in context. These numbers are part of this log equation right here. Now, we cannot do the log of a negative. So what that means is I can't actually have this as an answer, because I can't possibly do a negative log. Can't negative log. Not possible. Can't. Oh, I better write that a little bit better, sorry. It's not that I can't negative log. That wording's not quite right. It's that I can't log a negative. Alright, next example here. We're going to solve this lovely equation. Let's move on past these ones. We're going to solve for x. So, just like before, we need to be thinking, what are my log laws and how do I use them? So the first thing I'm going to be looking at is, we've got another little pesky 2. Now these are all log base e, right, because they're all ln, 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 so that's all good. However, we do have a little pesky 2 out the front here. So the first thing I'm going to do is I'm going to rewrite this equation. Ln of 2x plus 1 plus ln 2x take 1 equals ln 3 squared. So that little 2 that was out the front as a coefficient becomes a power once we put it back inside the log. Now, I'm actually going to move all my logs over to one side. So I'm going to have ln 2x plus 1 plus ln 2x minus 1 minus ln 3 squared equals 0. Now, I've got a couple log laws going on here. I've got these two, which are being added. Now, adding your logs means you're going to multiply the things inside the brackets. And then I've got this one on the end here that we are subtracting, which is the one that we're dividing. So this log is going to end up looking pretty funky. We're going to have ln of 2x plus 1 times 2x take 1 divided by 3 squared. And all of this is going to equal 0. Now, I could expand this first, or I can get rid of the log first. Now, just for the sake of my mental health, I'm going to probably get rid of that log first. Now, we saw before, I'm going to do e to the power of on both sides. And when I do that, this log is going to go away, because I've done e to the power of ln, which gets rid of that ln. And that's going to leave me with an e to the power of 0. So, I'm going to do two steps at once here. I'm still going to have this 2x plus 1 and this 2x take 1. And this e to the power of 0, I'm going to end up multiplying. E to the power of 0 is 1, multiplied by 9, because that's what 3 squared is. So all of that is going to just become 9. Now, I've still got one more lovely little step to do, and that step is I have to expand out these brackets here. So what I've got, 2x times 2x, 2x times negative 1, so I'm going to have 4x squared take 2x. On the bottom, 1 times 2x, 1 times negative 1, so I'm going to have plus 2x, and then I'm going to have take 1, and that is still equal to 9. This 2x and this 2x is going to cancel out, and I'm going to have 4x squared take 1 equals 9. Next thing I'm going to end up doing is just moving things around and doing some rearranging. So what I mean by that is, I'm going to bring this up here now so I can continue. So what that means is 4x squared take 1 equals 9. So 4x squared equals 9 plus 1, or 10. Then I'm going to divide by the 4. I can simplify this fraction down to 5 over 2. And then the last thing I would need to do is do the square root. So again, plus minus the square root of 5 over 2. Now, pause, can I have a plus minus on both sides? Well, I don't think I can, because let's think back to my answer from before. My answer needs to be going inside a log, and I can't have the negative of that number, which means I cannot possibly have this negative value. So I'm only going to have one value, the positive of that number. So that means I'm only going to have positive root 5 over 2. We could, of course, put that in our calculator, which we'll do now. And that's going to give us an answer of 1.58. Again, you've got your exact value solution, root 5 over 2, and then you've got your decimal solution of 1.58.